So anyways, we're out here at this bay here. And, you know, we're just eating shit, bored, just having fun. We had a pair of binoculars, so we figured, hey, let's go disprove these flat earthers once and for all. Over there, it's Biscayne here in South Florida. We have a pair of gigantic fucking binoculars here. As you can see, they're just massive. I know it's not a telescope. I know it's not anything, you know, particularly special, but it's big, powerful binoculars. So here we are on Google Maps. As you can see, we are zooming in right now. And our location was right near Black Point Park and Marina. We took a little trail out that goes out into the bay, and it gave us access and visibility to this location, this site. And we were able to go out far enough, and as you can see, the location we were looking at, including the lighthouse, was kind of near Key Biscayne, and it is a Cape Florida. There's a lighthouse here, as you guys will be able to see in a moment. It's Cape Florida, and it is, as you can see, it is approximately a total distance of 13.8 miles or 22.22 kilometers. That is the rough distance according to Google Maps. And if you go ahead and check here on the Anti-Flat Earth debunking website, metabunk.org, constantly debunking the flat earthers, so this isn't a biased source in any way. They have an earth curvature calculator, so you go ahead and you type in the distance in miles that we are from the lighthouse and the viewer height in feet. We are roughly 6 feet tall, and then you do it automatically tells you how much of the objects you see in the distance would have to be obscured over the curvature of the horizon. And as you can see, if you ignore refraction, 77.78 feet, almost 80 feet, would be obscured behind the Earth's curvature horizon. That's almost 8 stories if we're talking about a building. Almost 8 stories would be missing. If you're looking at these buildings, you wouldn't be able to see 8 stories. Now, if you take into account standard refraction, 63 feet would be hidden. So that's 6 stories. So if you have a 12-story building, roughly half the building would be obscured, disappeared behind the curvature of the horizon, if you're going with the refraction estimation. And, well, we set it up. There's a tripod here. We looked through, and let me see if I could even... maybe. Damn, this might work actually. What we can see is we can pretty much see everything. I mean, we can see fairly low level trees obscuring, you know, the base of the buildings and stuff. We can see a lighthouse, again, roughly 15 miles away. We can clearly see the majority, pretty much the entire damn lighthouse. It seems that way visually. We can even see little trees, you know, near the base of the lighthouse. So it looks like we can practically see the whole thing. It doesn't look like we're missing 100 feet, aka 10 stories. We look at the hotels or we look at the apartment buildings. It doesn't look like we're missing 10 stories of building. It looks like we can pretty much see the base of these buildings. Doesn't prove the earth is flat.
95 feet high.
What's 95 feet high?
The lighthouse.
The lighthouse is 95 feet high. So if we're okay, so my dad just did the research. He just Googled it, I suppose. There's a lighthouse that we can see off in the distance. He says the lighthouse is 95 feet tall. What's it called? El Farito, it's called?
No, Cape Florida.
Cape Florida Lighthouse. Cape Florida Lighthouse, 95 feet tall. According to metabunk.org, a lighthouse 13.8 miles away with a viewer height of 6 feet would cause 77 feet to disappear behind the curvature of the horizon. That's ignoring refraction. Now, when you look at this image here, does it look to you like 77 feet? Okay, you can say that's approximately 3/4 of the lighthouse would be missing. From the top to the bottom, the first 3/4 would be missing. We'd only be able to see the top quarter. Does it look to you like we can only see the top quarter? Now, if you take into account standard refraction according to the MetaBunk calculator, standard refraction would give us 63 feet. 63.74 feet would be missing. Again, even with the refraction, does it look like there's 63 feet of a 90-foot tall lighthouse missing based on what we captured with the binoculars from 13.8 miles away? It just doesn't look like it. And by the way, a lot of what you can see obscured, a lot of what's obscuring the base of the lighthouse, some of that is trees. See, there's this large line of trees over at Key Biscayne that extends out. And you can see it from where we were with the naked eye and easily with the binoculars. That's trees you're seeing right there. That black line that extends above the horizon, those are trees. Now, again, none of this proves that the Earth is flat. But it just, you know, it's not what you would expect. In fact, I asked my dad, who is a total skeptic. He does not think the Earth is flat. He thinks the flat Earth theory is just ridiculous. And I asked him, well, based on what you've seen through the binoculars now, was that what you expected to see? Did you expect to see more of the buildings obscured by the horizon and the curvature? My dad expected that he expected more would be obscured. He didn't expect to see so much. Again, none of this proves the Earth is flat. It's just a random experiment. So it's just fun, just eating shit. People say, oh, how dare you question with the shape of the Earth? Well, what's better, questioning what we're told, or just believing the Earth is flat, or believing the Earth is round because your first grade teacher told you, when you were fucking 6 years old? It's good. It's good to question. It's good to know why you believe things. And I've learned more about why we believe the Earth is a globe than I ever did before. It's a very interesting experiment, a very interesting way to learn the truth. So, not saying the Earth is flat. So as you guys can see, I was out there wearing my Vibram 5 fingers. Honestly, I'm super impressed by these. I didn't think they would be anywhere near as awesome as they are. If you'd like to see my full review of the Vibram 5 fingers, I'll put a link in the description below. Or if you'd like to buy a pair for yourself or somebody you know, I'll put a link. You can go buy these shoes as well in the description below. I really do highly recommend them if you're a fan of minimalist footwear or barefoot walking and running. Alright guys, so we're bored. So we figured, you know what? We have the entire east coast of Florida to have fun with this little experiment. And we're gonna travel north. Hopefully from there we'll also get a shot of the exact same buildings. It'll be a different angle, so that could affect things. But we're just gonna see what the difference in miles makes to what we can see and cannot see. So let's give it a try. All right, guys. So here's what we did. So again, this is where the lighthouse was, and this is where we were originally. A distance of 13.8 miles according to Google Maps. And what we ended up doing was we went from all the way down here and we drove all the way up to this area right here, right next to Redfish Grill. This is 11 miles. We drove roughly sort of northeast a bit from here all the way up here. 11 miles from our original location. And this is our new location now. Drag. And we are coming. Again, this is where the lighthouse is. Again, this is where the lighthouse is there. So now, after driving many miles northward, then northeast, we are now, according to Google Maps, we are total distance 6.28 miles away from the lighthouse. So let's do the math. 6.28 miles. Distance of 6.28 miles. Viewer height of 6 feet. And these are our new variables. The hidden amount would be 7.18 feet with no refraction. 7 feet of the horizon would basically be obscured by the curvature. If you consider standard refraction, it would be 5 feet hidden by the curvature.
You know what, Chris?
What?
Maybe one third of the trees was covered by the horizon.
Back when we were 14 miles away?
Yeah.
So you're saying that we can see more trees now?
You can see, and you can see the wall.
So you can see the seawall, which is how many feet above the water, you think, more or less?
The seawall is probably like, the seawall from the water is this high, 3 feet,
Yeah.
4 feet maybe.
Through the binoculars, as I will show you now, you can actually see the seawall. Now I currently have it on the lighthouse, as you can see. And if you look at where the ocean meets the trees, at the little base there is a thin sliver of white of what appears to be the seawall, concrete, etc. Now if you notice, the angle has changed. From 14 miles away, we could see what appeared to be the majority of the lighthouse, because all of those trees are now in the way. Before, the lighthouse was kind of sticking off the edge beyond the trees, and we can see most of it. That is a 95-foot tall lighthouse right there. So let's go ahead and let's move this fucker. We're gonna move it, and here are those buildings. You might recall these buildings from last time. And this is what we can see now. I see houses and structures in the foreground obstructing the base of the buildings, but can I somehow see more of the base? Really, the only thing we can see now that we really couldn't see before was probably the seawall. But we're gonna go ahead and compare the photos now. I was out there wearing my Vibram 5 fingers. Honestly, I'm super impressed by these. I didn't think they would be anywhere near as awesome as they are. If you'd like to see my full review of the Vibram 5 fingers, I'll put a link in the description below. Or if you'd like to buy a pair for yourself or somebody you know, I'll put a link. You can go buy these shoes as well in the description below. I really do highly recommend them if you're a fan of minimalist footwear or barefoot walking and running. Fight back against YouTube censorship by supporting me on Patreon. You'll also get access to exclusive, never-before-seen videos and other perks like monthly Google Hangouts with me, free books and t-shirts, and more.